So let's talk about building applications on a foundation of shared code. And generally what I'm talking about here is we build applications as a team. It might be a small team of 2 or 3 people. It might be a large team of 25 people. But no matter the size of the team, we want to make sure that our code base is as consistent and reliable and common as possible across all the different developers in the organization. And the only way to do that is to identify standards, identify shared code that implements those standards, and build the code from that foundation. And that's what I'd like to talk about here. So let's take a look. So what I'd like to do is offer an overall application development flow. And the idea here is that whenever we write software, it's an iterative process, which means anything we do today, we're going to come back and do again tomorrow. It could be because the users changed their mind, changed a requirement. It could be because we thought of a better way to do something. It could be because we had a bug in our code. But pretty much we're never going to do anything just once. And this iterative process should emphasize the establishment of a shared foundation of code based on standards. So let's take a look at my workflow, and I'll warn you, it's not rocket science. I don't think there's any major revelations here. It's just a way of conceiving of the overall steps that we have to take. First step, when we're building a new application, we need to define the requirements. What is it the user wants us to build? And we need to define our standards. So the requirements come from the users. The standards come from us. The standards say, here's how we're going to write our code this time to make sure that we meet all of our objectives and write some really fantastic code. Now, I assume that you all do this to some extent. The next step is something that I think we tend to skip or really diminish in importance, and I think it's the most important, which is take the standards that we define and build an application foundation based on those standards. In other words, from those standards, identify which of those standards can be pre-implemented by a set of common infrastructure components, programs, packages that everybody will use that form the foundation of the development. And once we have those in place, and it could be, hopefully it's something that we've used on previous projects, it's not brand new stuff each time, but once we have those pieces in place, then we start writing the actual code of the application. And this is probably composed of hundreds, thousands of different pieces, programs, triggers, tables, etc. And at some point, we put together an iteration of the application. Here are the 5,000 elements. They pretty much hang together. They sort of work, which means that the next step is that we can validate that iteration. We test the code, both from the standpoint of a developer doing code or unit testing and the users doing acceptance testing. We review our code as a whole to identify whether or not we're meeting our standards. We optimize the code, identifying bottlenecks at the global level, the entire code base. And usually, when we do this kind of validation iteration, the news is not so great. It could be that the users say, wait a minute, we've changed our minds, or we have a change in our standards that we need to implement. It could be that the foundation has a bug in it. Most of the time, though, the application iteration has some bugs, and we need to go back and fix it. And we do this over and over and over again. And at some point, the product goes to production. The application is rolled out to the users, rolled out to the QA organization. They approve it, it goes out. And then, of course, we get more feedback. No, I've changed my mind about something in my application. No, that's not how we wanted it to work, or hey, we found some more bugs. So we go through these iterations over and over and over again. But the point I want to make here is that if we start with our requirements and we don't really take a lot of time to set standards and we dive in to writing our application code before defining our foundation, we're going to spend a lot more time writing code and we're going to spend a lot more time fixing bugs than we would if we took the time to build that solid foundation and then made everything else a layer of code on top of the foundation. Now, let's talk in a little bit more detail about rules and standards, because a lot of times everybody's got some kind of standard, some kind of naming conventions document or coding standards document, but often it remains a static document and it's not really applied in any sort of active way in development. Here's my view about rules and standards. First of all, we really need a lot of rules and standards. I think developers should welcome standards. And the reason I point this out and emphasize it is that in my experience, both myself personally and other people, I find programmers to be a fairly anarchistic bunch. I think that the way I format my code is the best. I think that the way I write my code is the best. Don't you tell me what to do. And unfortunately, that's a phony kind of freedom and stand in principle for your coding quality. I believe that we should accept as many standards as possible, even if we don't agree with all of them, because the more we standardize, the more our code is predictable across the entire team of developers, the more consistent it is. And that kind of consistency and predictability gives us a lot of advantages. It makes it easier to analyze the quality of our code, to automate processes for our code, for example, if naming conventions are very strongly followed. But even if we do all that, we have to do more than simply write down the rules. You can't just write a document that says, here's how to do this, here's how to do that. Because for the most part, people read it at best and toss it in their drawer and never look at it again. So I think that in addition to setting rules, you also have to think about how to systematize how the rules will be followed. Essentially, what you want to do is establish new habits so that you don't even have to think about your standards and your naming conventions. As you write your code, it just happens naturally. That's the real sign of success of a set of standards and naming conventions. People don't even realize they're following them. They don't have to check the document. It's been internalized through systematic process, and you develop new habits. Second, and even more important, automate the implementation of rules whenever possible. In other words, rather than having to teach somebody one of your best practices, you should design your environment so that they can automatically take advantage of the best practices, follow the rules without even realizing they're doing it. Automate the development of your code as much as possible. Now, obviously, you can't automate 100% development. You would be out of a job. And in fact, that's never been particularly practical. So there's always going to be a lot of code that you have to write, but the more we can automate, the better. And finally, validate that the rules were followed. All too often, we set rules, we define standards, but we never go back and check later. What's the point of that? People realize very quickly if what they're doing is not going to be looked at, is not going to be checked, and they will not pay attention to the rules, at least the ones that bother them. So it's very important that we set up a process for reviewing code. And code review should be both peer and automated. In other words, other developers should look at my code and give me feedback. And there should be automated mechanisms that do a much more thorough and sweeping job of analyzing the quality of our code, checking them against our standards, and identifying flaws or drawbacks. So in a lot of the videos that I'm presenting in this series, we'll take a look at rules for things like error management, writing SQL, etc. But then I'll follow up with ideas for systematizing the following of the rules and automating the implementation of the rules. And we have a whole separate section towards the end of the series on validating that rules were followed, or code review. Now, in terms of the different aspects of that application foundation that I think is so important, I want to focus in this video series on just three. The first is setting coding conventions and naming standards, aiming for maximum consistency in the code that's written by everybody on the team, but without setting up a police state about it. Now, and the point here is that we'll talk about some coding conventions and naming standards. I'm not going to go into details. I'll point you to a document you can download. What I will focus on here are the approach you should take in making these rules active in your environment. So the systematizing and automating. Next, we'll take a look at error management. What to do when things go wrong. How to raise, log, handle errors. Now again, we're not going to cover this in tremendous depth, but I'm going to talk about some general rules, and I'm going to offer you a freeware product from Quest that I wrote called the Quest Error Manager that will essentially give you a common shared utility that everybody will be able to take advantage of. And finally, and I think most importantly from the standpoint of an application foundation, we'll take a look at SQL access, the data layer. How do you write the SQL statements in your PL SQL programs? For the most part, we take SQL completely for granted in the world of PL SQL, and I think that's an enormous problem. And what I'll talk about is that you're actually addicted to writing SQL as a part of your PL SQL construction. And we'll talk about how to break that addiction and completely change the approach you take and how you see SQL within a PL SQL environment. And we'll take a closer look at each of these over the next three elements in my video series.